According to the National Electrical Code, NEC 2023, Article 450.42, 8.1, Ground Fault Circuit Interrupter, GFCI protection is required for all 120 volts, single-phase, 15 and 20 amps receptacles located outdoors, including those for animal watering equipment. When using a tank heater that is protected by an enclosure located in a field, there are certain challenges for GFCI protection. Underground polyvinyl chloride, PVC, conduit and an enclosure can protect the heater from some moisture, but it is still possible for moisture to penetrate the system, causing nuisance tripping of the GFCI. The heater being located a distance away from the electrical panel makes it difficult to reset the GFCI if it trips. A possible solution to address these concerns is to install a Class A GFCI breaker in the panel. Class A GFCIs are designed to be less sensitive to nuisance tripping caused by moisture and ground faults, making them more suitable for outdoor applications. The tank heater should be protected from lightning surges using a lightning arrestor or surge protector. An electrical disconnect should be installed near the tank for easy access in case of an emergency. The heater, GFCI, and other electrical components should be inspected and maintained regularly to ensure proper operation and safety. While GFCI protection is required by code for outdoor animal watering equipment, the specific challenges of this location may warrant the use of a Class A GFCI breaker to minimize nuisance tripping and ensure the safety of the cattle and horses. Regular inspection and maintenance are also crucial for ensuring the safe and efficient operation of the tank heater. Let's delve into some of these points further. Firstly, it's important to understand the fundamental purpose of a GFCI. A GFCI is designed to protect people from electrical shock. It does this by monitoring the current flowing to and from an appliance or device. If there's a difference of even a few milliamperes between the current going out and the current returning, the GFCI trips, quickly cutting off the power. This difference indicates that some of the current is leaking to ground, potentially through a person. In the context of a stock tank heater, several scenarios could lead to ground faults. The heater itself could develop a fault, with its internal wiring becoming compromised and allowing current to leak into the water. Animals could damage the cord or connections, creating a path for current to flow to ground. Moisture, as mentioned earlier, is a significant factor in outdoor environments. Condensation, rain, or even just damp ground can create conductive paths, increasing the risk of ground faults. Article 450.42. 8.1 of the NEC mandates GFCI protection for 120 volts, single-phase, 15 and 20 amps receptacles in outdoor locations where livestock watering equipment is used. This is because livestock, especially when standing in water, are particularly vulnerable to electric shock. Even a small amount of current can be harmful or even fatal. The code aims to mitigate this risk by requiring GFCI protection. The use of underground PVC conduit is a good practice for protecting the wiring from physical damage and moisture. However, it's not a foolproof solution. Water can still penetrate the conduit through fittings or if the conduit is damaged. The T11 box provides a further layer of protection for the receptacle itself, but again, it's not completely immune to moisture. The distance of 150 feet from the panel to the tank heater location presents a challenge for GFCI protection. Longer wire runs can increase the likelihood of voltage drop and can also make the GFCI more susceptible to nuisance tripping. The increased resistance of the longer wire run can contribute to a slight imbalance in the current flow, which the GFCI may interpret as a ground fault. A Class A GFCI is designed to trip when it detects a ground fault of 6 mA or more. While this level of sensitivity is necessary for protecting people from electric shock, it can also lead to nuisance tripping in certain environments. The Class A GFCI breaker is less sensitive to nuisance tripping caused by moisture and ground faults, making them more suitable for outdoor applications. These types of GFCI breakers typically incorporate advanced filtering and signal processing techniques to distinguish between genuine ground faults and transient electrical noise. They are better able to tolerate the slight imbalances in current flow that can occur in long wire runs or in damp environments. While a Class A GFCI breaker can help to reduce nuisance tripping, it's still important to address the underlying causes of ground faults. Firstly, ensure that all wiring and connections are properly installed and protected from moisture. Use weatherproof connectors and seal any openings in the conduit or enclosure. Secondly, regularly inspect the tank heater and its cord for any signs of damage. Replace the heater or cord if any damage is found. Thirdly, consider using a high quality GFCI receptacle. Some GFCI receptacles are designed to be more resistant to nuisance tripping than others. Lightning protection is another important consideration for outdoor electrical equipment. Lightning strikes can induce high voltage surges in electrical wiring, which can damage the tank heater, the GFCI, and other electrical components. A lightning arrestor or surge protector installed at the electrical panel can help to protect the equipment from these surges. The lightning arrestor diverts the surge to ground, preventing it from reaching the equipment. An electrical disconnect is a safety device that allows you to quickly and easily shut off the power to the tank heater in case of an emergency. The disconnect should be located near the tank and should be readily accessible. Firstly, ensure that the disconnect is properly sized for the load. Secondly, make sure that the disconnect is installed in a weatherproof enclosure. Thirdly, label the disconnect clearly so that it can be easily identified in an emergency. Regular inspection and maintenance are essential for ensuring the safe and reliable operation of the tank heater and its associated electrical components. Regularly inspect the tank heater for any signs of damage or corrosion. Check the cord for any cracks or fraying. Test the GFCI receptacle or breaker regularly to ensure that it is functioning properly. Firstly, use a GFCI tester to verify that the GFCI trips when a ground fault is simulated. Secondly, inspect the wiring and connections for any signs of loose connections or corrosion. Thirdly, clean the enclosure and receptacle to remove any dirt or debris. The information is based on the NEC 2023, however, electrical codes can vary from jurisdiction to jurisdiction. Always consult with a qualified electrician to ensure that your installation complies with all applicable codes and regulations. The installation of a tank heater and GFCI protection should be performed by a qualified electrician. Incorrect installation can be dangerous and can void the warranty on the equipment. Before beginning any electrical work, always disconnect the power at the breaker panel. Wear appropriate personal protective equipment, such as gloves and eye protection. Follow all applicable safety procedures. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations regarding your installation. Here are some additional considerations for GFCI protection of stock tank heaters. Firstly, consider the type of livestock that will be using the tank. Some animals, such as horses, are more sensitive to electric shock than others. If you are using the tank for sensitive animals, you may want to consider using a more sensitive GFCI. Secondly, consider the size of the tank. Larger tanks may require a more powerful heater, which may draw more current. Make sure that the GFCI is rated for the current draw of the heater. Thirdly, consider the water quality. Water with high mineral content can be more conductive, which can increase the risk of ground faults. If you are using the tank with hot water, you may want to consider using a more robust GFCI. GFCI protection is a critical safety measure for outdoor electrical equipment, particularly in areas where livestock are present. While nuisance tripping can be a concern, it's important to prioritize safety and ensure that the equipment is properly protected. By following the recommendations outlined in this discussion and consulting with a qualified electrician, you can create a safe and reliable electrical system for your stock tank heater. Now to recap, firstly, GFCI protection is required by code for outdoor animal watering equipment. Secondly, challenges include moisture, inaccessibility, and potential nuisance tripping. Thirdly, a Class A GFCI breaker can minimize nuisance tripper. Fourthly, lightning protection is essential. Fifthly, an electrical disconnect should be installed nearby. Sixthly, regular inspection and maintenance are crucial. Seventhly, consult with a qualified electrician for proper installation and code compliance. Eighthly, consider the type of livestock, tank size, and water quality. Ninthly, prioritize safety and reliability. Tenthly, follow the recommendations and guidelines for a safe and effective system. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The NEC is a complex document and it can be difficult to interpret. If you have any questions about the NEC, consult with a qualified electrician. The NEC is not the only code that may apply to your installation. Local codes may also apply. Consult with your local building department to determine which codes apply to your installation. Electrical work can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician. A qualified electrician will be able to safely and properly install your tank heater and GFCI protection. A qualified electrician will also be able to inspect your existing electrical system to ensure that it is safe and up to code. The cost of hiring a qualified electrician is an investment in your safety. The cost of a GFCI breaker is relatively low, but the peace of mind that it provides is invaluable. Do not skimp on safety when it comes to electricity. Always use high-quality components and follow all applicable codes and regulations. The safety of your livestock and yourself depends on it. Now that we've covered the essentials, let's consider a few advanced scenarios. What if you're dealing with an older installation that doesn't have grounding conductors run to the T11 box? In this case, you might consider installing a GFCI receptacle in the box and labeling it GFCI protected equipment ground not required. This configuration relies on the GFCI to interrupt the circuit in the event of a ground fault, even without a direct ground connection. However, it's crucial to understand that this approach doesn't provide the same level of protection as a properly grounded system. In another scenario, you might be considering using a submersible heater that's designed to be fully immersed in the water. These heaters typically have a built-in ground fault sensor that will shut off the heater if it detects a ground fault. However, it's still recommended to provide GFCI protection at the receptacle or breaker as an additional layer of safety. What about using a timer to control the tank heater? Timers can be a great way to save energy and prevent the water from overheating. However, it's important to choose a timer that's rated for outdoor use and that can handle the current draw of the heater. Also, make sure that the timer doesn't interfere with the GFCI protection. The timer should be installed on the line side of the GFCI so that the GFCI will still trip if there's a ground fault, even when the timer is off. If you're planning to use multiple tank heaters, you'll need to make sure that the GFCI is properly sized to handle the combined current draw of all the heaters. It's also a good idea to use separate GFCI breakers for each heater so that a ground fault in one heater won't shut off all of the heaters. Always consult with a qualified electrician to determine the appropriate GFCI protection for your specific application.